Okay, so let's get started. Okay, the first few minutes, I just want to do something similar to last time, is ask if you have still some hurdles with any of the ideas that we discussed last week. Hello. Yeah. Yeah, any issues with last time? Oh, no. So I'm just in the same, it's the same server that's been running for last few weeks. So okay, so we'll follow, basically we'll follow, do a step-by-step of the tutorial link that I just shared. Okay, so I strongly encourage folks to do it simultaneously with me, because it's such a useful utility that it will be useful for your projects, okay, whenever you do a thing. So what we'll do is first install MLflow. So please, I don't think I just. Oh, you want to check the screen command? Okay, you forgot your password. So you can do screen -R. Okay, so to resume, like you can also check which screens are open. So there's one open, but screen -R will get you back into that. So you can Control C and restart the thing if you want. I don't think this is the correct. So let's actually just use pip. No. So pip install MLflow. So I mean, we can also use Conda, but yeah, I think I mean, you can use the Conda version of this. I'm sure it is there. Yeah. I don't want to Google it right now, but yeah. Okay, you can see that it's actually installing a lot of packages, which are probably related to. Some of them are related to third parties like Azure or Databricks or Google Cloud and so on. That's because you can send these. So they also have hosted versions of MLflow service, so you can actually do a lot more. But let's actually now clone the repository. So okay, we did not discuss much about Git in this course, but hopefully we will next time. Okay, so this is just the repository. What we want to get to is the examples folder. you can see there are a lot of examples, but we'll pick a simple example that was shown in the actually open all these. So I just navigated to the I cloned MLflow and then just navigated to examples, sklearn, elastic wine, and then in that folder there are multiple files. I just opened relevant ones. So we're able to clone the repository. So something like git clone. So we're just following the steps in the this step. So we're just following. So if you wanna so just run this. Okay. So git clone. Okay, so once you're done with that, so let's actually look at the code here. So it's exactly what is there in train. Okay, so this train, not this train here has the same code, but let's actually look at. I guess it doesn't matter. So let's look at this. Okay, it has line numbering. So there's a bunch of imports. Okay, so these imports are pretty standard. OS and system are just to get system variables and OS name and things like that, and environment variables and so on. These should be pretty standard and standard like NumPy and pandas. And then these are also related to just model training, right? So linear model selection, metrics, right? And then what is new is I mean, so URL parts, we'll see where it comes. And so the what's new is MLflow and MLflow.sklearn. Okay, so MLflow is agnostic to different model building tools. So for the sklearn compatibility, we want to import that. Okay. So similarly, if you're using light GVM, for example, then there's MLflow light GVM component that you need to import. Okay. So here's a code for logging. Okay. So logging is a feature available in Python standard library. You can actually log warnings, log errors, log different information on the either directly to the command line or into a file. Okay, so you can do those things. So you can see some evaluation metrics, RMSE between actual predicted and actual values. Okay, so let's actually focus on what's going on inside the main file. Okay, so it's just saying setting warnings, ignore the so there's some filtering of warnings going on, and then some np.random.seed. Okay, that's just for repeatability of this thing. So okay, so if the data is not there, so we already have wine quality, but here we're just reading the file from the URL. Okay, so it's just trying to read the CSV file from the URL. So instead of fetching data, so this is just remote fetching from server which has that file directly, which is readable. Okay, so I think we have wine quality. It's called wine quality. What's it? I'm trying to figure out. Yeah. Okay, maybe we can use that. But okay, so that's that part. So then the usual machine learning aspects. So we'll probably not spend much time here, but just train the split of the batch data, calling dropping, basically getting the labels and the features. Okay, train the features and labels. And then here's an interesting thing which I'm sure most of you know, but here you can set default values for your parameters for your training, and also be flexible enough to take values from the command line if in case there are some command line parameters you want to pass. Okay, so it's just checking. Here it's just assuming that system.argv is just number of arguments. Okay, sorry. sys.argv is a list of arguments, okay, that you can pass while calling Python file name.py. Here Python train.py. When you're calling that, after train.py, you can put a space and then give a couple of arguments. Okay, if you give two arguments, then sys.argv will be length 2. If length is strictly greater than 1, then you pick the first element. Sorry, so argv will also have a Python and file name also. So we can check that, in a if you want to try. But so this will have the extra arguments. Okay, so we are just assuming that the first argument is a argument called alpha. The second argument is called L1 ratio. So there are two numbers that are useful while training. Okay, so if you don't give default value, so if you don't give any arguments, it's just saying take values 0.5 and 0.5. Okay, so that's fine. Now you can see what the use of MLflow is. It's actually very it's just pretty much 1 or 2 lines. Okay, so there are a few more lines at the bottom for logging, but it's literally saying MLflow with MLflow.start underscore run. Instantiate your model, ElasticNet model from sklearn, call model.fit, make predictions, and get evaluation metrics. So this is pretty standard. These 4 lines are what you would have done without MLflow as well. Okay, and these are just printouts, right? Now, with MLflow start.run, it's going to remember actually the full training curve. Okay, train curve. And then you can explicitly log things which are not, which are kind of not standard. Like, for example, this is something that we computed, or MAE we computed. So things that we computed and things that we want to track as part of this run of the model, we just remember them. This part is just extra. If you want to have an extra URL for this. Otherwise, it's just yeah. So this registration of model is just an extra feature. So it's mostly just for in case you have multiple models and you want to invoke one of them or not. So let me actually give me 1 second. All right. Yeah, sorry, I forgot to share the screen on Zoom. So okay, but so just for folks who are remote, we've been just going through this. Whatever you saw, it was just static, but it was exactly the same code. We were just going through line by line to kind of understand what the different parts of the code were. Okay. So what you did not see was the second bottom part of that, whatever you were seeing earlier. Anyway, so that's the training set. So actually, let's okay. So if you just run Python train.py, we could use the wine quality. Okay, I need to really check if it's shared or not. Sharing, recording, yeah. Okay, so we run the model. It's just printed out what the performance is and all that. So you can see there was a new folder that got created, ML runs. Okay, so what we can do is actually directly try to get. So ML runs has the data corresponding to this single run that we did. So we can actually do, as I said, command line argument. You can do 0.1 for alpha and maybe 0.7 for this L1 ratio. There's 2 hyperparameters that we had to choose for this ElasticNet model. So we can run it as well. slightly different performance, and so on. Okay, so all that is logged in the ML runs folder, and then we can use MLflow UI. So now this is again essentially a web server that's running at port 5000. I'm trying to remember if this is exposed to the world. Okay, so port 5000 is not exposed to the world. So okay, so I can actually go back to bash and try to see if I can port forward 5000 to 5000. Okay, so I'm doing a second port forwarding via SSH. Okay, so I port forward twice. Okay, so first one was for the Jupyter instance itself, second one was for this. So let's see if okay, so this should be what you should see. I think it looks like it's zoomed in. Okay, so these were the two runs. So you can already see some interface where you can see we run the training twice. Okay, and you can see there is some what is the PY file that was run, who was the user, and you can see the table of what was the mean absolute error, R square, RMSE, you know, the things that you explicitly track. Okay, so this is like model version, right? So imagine, like, it's very convenient, right? So imagine doing this post processing using pandas, or showing it in Excel sheets and so on. So if you click on one of them, right? I mean, it's the same thing. What is the alpha metrics and so on. So actually, I believe we should be able to okay, so these are not tracked. So okay, let me come back here. So what I want to show was that you can actually track not just these variable values, but you can also track the loss curves. Okay, as a function of report, which is not being tracked here. But so is everybody okay with this? Any issues getting up to this level? I mean, coming to this page. Okay. Yeah, so you can see that it's actually tracked several things. There's a couple of other files, and we're gonna briefly discuss them. Okay, so those are the metadata that you can see, like ML model, conda.yaml, and requirements of text. We'll briefly mention that. In fact, we'll look at it right now. Tutorial. Okay, so what we did is something like this. So here you can see this is a screenshot of a run, the several runs, and then different different hyperparameters basically, and then metrics. Okay, so next is basically portability. Okay, so very similar to how we can. So with model deployment, if you don't want the second user to really know the nitty-gritty details of your model, they just want it for inference, then you can always give them a Docker file with your PY file, or actually just give them an image through a registry, okay, through Google Registry or Docker Hub or something like that. So similarly, the idea is the idea with MLflow is that you wanna make somebody else run training loops. Okay, so if they want to try out a different hyperparameter, a different some change the post processing, pre processing, they want to do extra stuff, then along with the along with the train file, you can pass along a YAML file. Okay, YAML file is just a text file. YAML ain't markup language, some recursive name for this, but it's just text file. And so you pass along with the train file a couple of text files. Okay, so what are these text files? So first one is called I guess first one is okay, let me actually open the files. Okay, so one is conda.yaml. So it's actually, if you use conda, so if you have, ideally you want to have conda with this with MLflow so that it works nicely. Otherwise, you can also work with pip. So what it's just saying is that, hey, to run this particular file train.py, you just need some dependencies. Okay, so you need Python 3.7, at least pip, scikit-learn, MLflow, and panda. Okay, so it's just a kind of requirement file. In fact, the other file, I don't know if you have requirements or text. If you not, you can also have a requirements or text which says the same thing. The more interesting file is ML project. This is specific to MLflow. It's just saying where to get, how to install the prerequisites needed for this training aspect, and then what are the what's the way in which you're gonna invoke this training. So there's just an extra metadata file, just setting up the environment and setting up a way to start doing new runs on this using this train file. So it's just a extra feature. We can do the same with pip as well, but I don't think we want to go into that detail. There's also model serving. So you can see in the tutorial, they also mention pip, but that's fine. So we can look at serving the model. So we can actually serve the model very similar to how we did with Flask. Okay, so it actually, just like there's this UI that we got, you're able to actually serve the model. So we did not register the model, I believe. Okay, actually, we just have experiments. Oh, that doesn't work. Oh. No, it's fine. We can default the experiment itself. So what you can do is sure. No. Yeah, there's actually more process, but we'll kind of not work on that because we just wanted to get a feel for versioning. So what you can do is actually export or basically publish a model. That's basically what you can do. So yeah, for example, you can just run model serve. Where is the model? If you can just say where the model is, and some port, and that's good enough to serve the model. Okay, so we can do this. And so if you do that, then you can use curl or something else to message this model, give some input, and then get an output. And in fact, below they show you how to do that, like this. Okay. In fact, you can do so curl is you don't have to do via curl. You can use request package to also do the same thing. You just need to make a post request. And here, in fact, they are doing a post request with not a JSON but a data, which is basically a string version of the actual data. Which is these are all the values, and given these values, produce the output, right? So you can pass on feature vectors like this. So we're not going to retry that because we've already seen like 3 different ways to do the same model deployment. Yeah. Okay. So any questions about MLflow? What I wanted to summarize, what I wanted to show was just kind of this experiment tracking or model tracking versioning, and deployment of the model is something we'll skip here for this version. This is actually in our own. It's in the server, right? So this is in our remote machine. So we just started MLflow UI in the same directory where we had. So it's basically using this information, this folder in the same. So we were in this folder. We ran MLflow.ui after running the train.py a couple of times, and so it created this folder with actually, if you open it, it will have lots of, it'll basically show you exactly those long strings, and inside those strings you have what is the artifacts, what was logged, and all that. Okay, so what the UI is doing is just showing the same showing that stuff in a nice way, using a GUI.
This is on our remote machine.
In our machine, yeah. So imagine you have a training machine. As long as it has the Conda or Python installed, you can get MLflow with. It has some dependencies, as you saw with sklearn. You need to have sklearn, of course, but also Conda. If you have that, then it will create these files. So I believe
so Professor, when I try running MLflow UI, it gives me a connection error. It does not connect to that.
connection.
Yeah.
Wait, did you just run it after something like this?
Yes. Yeah. After running the train.py a couple
Yeah.
of times,
Yeah.
this it does not connect. Retries and then it cannot connect.
It's not able to start the server, basically.
Yeah.
Okay, so I don't think we can real-time debug this. No. So it's probably maybe it's not able to get that port and run it. I don't know if you're running a Flask app at the same port.
Yeah, maybe I don't have to check that.
Yeah, because it's also defaulting to port 5000. It could be it could be a port issue. So if you want to specify a different port, I believe you can do -p port number, but I don't want to.
Yeah, I'll try it.
Yeah. Okay, so that's about MLflow. So we're gonna switch back to our. So that's about versioning. Okay, this is just the tip of the iceberg. This is not the only tool. There are many other versioning tools. Um, so what we'll do next is come back to chapter 5, which is about model pipelines. Okay, so remember what we want to do was we did testing last time. We did a little bit of versioning today, and hopefully the rest of the session we're gonna try to do a little bit on scheduling, okay, which in particular is cron-based scheduling as well as Airflow-based scheduling. So let's talk about scheduling a little bit more, understand where it's used. Okay? So okay, so data science workflows is just a name that I'm using to kind of motivate this situation, which is basically uh, there's a need for workflow tools and tools to manage your data science process the moment there's more than one person. If it's only one person, you know which folders, what sequence of steps to run, and so on, right? But the moment in typically in a professional setting, there's going to be multiple business analysts, multiple ML engineers, multiple data scientists, and so on. Okay, so there's a lot of and in that case, these types of workflow tools or management tools come into picture, and they help understand what's going on with your data science team. So we'll only be focusing on a specific aspect of it, which is which is pipelines. Okay, so pipelines are just sequence of steps. Okay, so basically, for example, touching different data sources, application databases, or data warehouses, or even data lakes. Just think of them as more and more raw data, and then generating features, imputation, feature engineering, and also generating train models. So there are different tasks, right? Subtasks that we have to do, and this could be divided across people, across jobs, okay, across I guess machines also. So while doing all these related tasks, okay, maybe the exception of exploration and some thinking. So tasks which are kind of mechanical, they can be thought of as like modular blocks or jobs, okay, steps that can be chained in a directed fashion. So you can say task 1, task 2, task 3, task 4, task 5. So generally these are after you have done your initial model building process where you are doing exploration and figuring out what to build first of all. But once you've built version 1, version 2, version 3, version 4 may have similar flow of working with data, right? So what you do is you start thinking about this process as a chain or as a directed acyclic graph. Okay, so what is a directed acyclic graph? It's just a graph with directed edges and nodes. So here you can think of nodes as jobs, and so one job uh, can lead to some succeeding jobs, and those succeeding jobs can lead to some other succeeding jobs. Okay? So think of the first job, let's say data fetch, and the succeeding jobs can be feature engineering imputation, and then after that maybe model building process itself, and then after that dockerizing the model, and then deploying the model. So these are all tasks. You can think of that as a sequence of steps. So what we want is some features while managing these steps. Okay, so that's what workflow tools bring to the table. First thing, I mean, doesn't have to be the first thing, but no particular order. First of all, there may not be just one pipeline. Okay, so people may be building a churn model, people may be building a recommendation model, people may be building a uplift model. These are all like different types of models that you'll see, especially in marketing domain, right? So you want to, if you have a data science team, okay, then they have to manage multiple such models and all the things that relate to those models, right? So multiple pipelines. Right? You also want to, typically these pipelines have to be refreshed. Okay, so it's not like you build once and done. Okay, then you will not be having the job. So so you have to kind of maintain the models, update data, with updated data, build models and again, right? So that's one feature that we want. So we want something to manage multiple pipelines, updating the updating jobs, rerunning the jobs basically, and also these tools should have extra features like, hey, if the previous job did not run, notify person X, Y, and Z while trying to redo this job. Okay, and this is something that you'll see in modern systems. So there's a huge ecosystem of tools like PagerDuty and notification services, which kind of alert the on-call person or the concerned engineer if a step fails. Okay, so there are many things like that. So ultimately, this is about automation, right? So this is like same thing with the model deployment part. So instead of needing like 5 people dealing with various different parts, you could just write your script and try serverless or Docker or something like that, right? So it's about automation, and what they let you do, what they typically let you do, a single user kind of, what they typically let the team, a small team, do is specify these pipelines as DAGs or directed acyclic graphs, and deal with dependencies between these jobs. Okay, so maybe the data fetch job has to happen before imputation, let's say data engineering job has to be run, and so on. And then also schedule blocks. Okay, the types of things that we just mentioned, while being able to do extra things for reliability and so on. Okay, so here is a list of tools which may be outdated by this time. We saw MLflow mostly for versioning, but MLflow can also be used for not so much for job scheduling, but for some of the management aspects. Right? We saw we can manage models themselves, but there are a lot of names with flow in them. But basically, many of these tools are kind of comparable to each other with similar feature set, which is this, right? So ability to manage these ML processes, ability to deal with dependencies and failures, and ability to schedule them again and again. Okay. So what we'll do in this section is just focus on the simplest one of the aspects, which is scheduling. Okay. So we'll try to set up our minimum working example, and then try to use Cron as a first way to at least rerun the same thing again and again. Okay. So Cron, so Cron is basically a daemon, again a service running on most Linux machines, including our AWS server, which can keep triggering the same Python file, for example, again and again. Okay. So that's essentially what it does. Okay. So you may say, hey, why do we need another tool to just call a function again and again? We can actually do that even in Python itself. So in Python, you can say for, or do a for loop, or you can say, hey, at 10 a.m. start this, call this function, at 15 a.m. call this other function. You can do that. There are multiple tools to do the same job. Generally, when you run a Python script, unless you make it such that it runs as a background process, like how Cron is, it will be a foreground process. It will block your UI. Okay, so it will block your command prompt, for example. So you have to just deal with those extra things. So which cron does, for you already. So, and then we'll look at Airflow. Okay, Airflow is where you can actually visually see the DAGs. Okay, the directed acyclic jobs. So let me. So before we get hands-on into setting up a minimum viable example where we do cron and Airflow and also look at the details, let me also show you the I should bookmark these. A diagram so that I keep referring to DAGs. So let's actually look at the diagram. Oh, there's the slides. Yeah. Yeah. So just to get fine, solidify our understanding. So mostly I just mean this, right? Something like an extract, transform, load job, ETL. It's not just one job, but whatever is related to ETL activities, model training, and then saving predictions, saving model logs, sending predictions, sending the model itself to somewhere else, and so on. Okay. So if you need to repeat them daily or whatever the schedule, then you would use tools like the ones I'm mentioning. Okay, Cron and Airflow. So here's an example of a batch model retraining process. Okay, so this is in fact a diagram from Airflow, Apache Airflow. So here's the same diagram what we saw in the previous slide, but maybe more steps. So there's a data ingestion, data analysis, data integrity check, and there's some extra. Okay, actually this is not related to model training, but it's just a bunch of steps, right? So for example, describe the integrity, email if there is an error, save, report. So it's a reporting sequence of jobs that you can modularize and then run them repeatedly. Okay? Yeah, so we'll get to this overview when we get to Airflow. So let me not talk about it for a second. Okay, so we'll start with what I want to do is again spend a little bit more time on a couple of vocabulary items. Okay, so one and then look at Cron. Okay? So let's really focus on one type of jobs or process, training workflows. Okay? Just model training workflows. Okay? So the common tasks here are generally data extraction, train the model, predict on a test set, typically train predict things, and then save the results to a typically a database or elsewhere. Okay, so in this training workflows, there are two types of workflows. Okay, one is called persistent model workflow, and the second one is called transient model workflow. Okay, so I just want to point them out because you may be like it will come up, for example, in professional setting. So what is persistent model pipeline? This is where model updating is decoupled with data updating or test cases updating. Okay, so which is that model is updated monthly, whereas your predictions are updated every day, every hour. So think of like weather prediction, right? So weather prediction model itself is not updated daily, or maybe not updated every hour, but whether the predictions themselves are kind of, you generate new predictions every hour. So maybe you generate it every hour, and so every time somebody queries, they potentially get new updates. Maybe as the predictions update. Okay, so the model update is decoupled with data and predictions themselves. Okay, data fetching and predictions. So here the data fetch is not for training. Here data fetch is for new features for which you want to make predictions. So that's called persistent model pipeline. Okay, so that will require a different DAG. In contrast, this is the most typically what people think do, at least as a starting point, which is transient model pipeline. So they have this process where they fetch the data, call model.fit, call model.predict, and then it ends, right? So that we saw that in fact in the previous MLflow example. So if you just think of like that file, and if you rerun that file, okay, it's like you're creating a new model every time, right? So the previous model, whatever you trained, is gone. Okay, and it's not gone, but it's basically you're not reusing it. Okay, so it's tightly coupled with fetching of new data and prediction. So every time you want to make a new prediction, let's say you're making daily predictions for let's say the stock market, then you make the predictions, but as an intermediate step, you're building the model, building a new model from scratch as well. Okay, so that's a different mode of operation. That's transient model pipeline. So any questions about these two? So okay, so I don't want to scroll over the full example here, but basically the example is talking about doing a lot of things. We'll probably not do all of those. So we have an example of a transient pipeline in the notes, which does getting the training data from a specific, using a specific package, train a recommendation model, use the model to predict recommendations for a new set of test users, and save the results in a particular, I guess, third-party service called Google BigQuery. So these were the steps identified, and then each one is like a job, modular job. Here the directed acyclic graph is like a chain, is a linear, step 1, step 2, step 3, step 4. But you can imagine some panning out and all that. So that's the pipeline listed here, but I don't want to go through the details of the code. Yeah, I'll skip that. Oh, there's some errors as well. Okay. So I'll skip that because I want to talk about cron. And in the context of cron, we'll schedule some things. Okay, some of the files that we already have. So instead of doing this, then we can do something else. So yeah, let me actually talk about cron. Any questions so far? This section was just talking about two types of pipelines, transient and persistent model pipelines. Okay, so if not, let's talk about cron jobs, or cron as a way to schedule repeated activities. So to discuss cron, I don't think we need to depend on the previous output. So let me skip to directly the section. So actually, there's a lot of steps here, mostly talking about how to use Google BigQuery as a part of your job, because in one of your jobs, you will have to send the predictions to Google BigQuery, but I'm skipping that. So let me directly get to this sub point. Okay. So, I mean, what happens is before that is just building of a particular image. We already have a couple of images that we built before, so we can always use them as standard. So we don't have to do recommendation training pipeline. Okay, so cron is a really old tool. It's a command line service for scheduling of programs, not just Python scripts, any program in Linux, on Linux systems. I don't know what's the equivalent in Windows, but there are, these tools are available. So cron is available in both Mac and Linux for this task. It's, like I said, it says its name originates from Greek. So why are we looking at cron, right? So this is the simplest scheduling tool. It comes packaged with pretty much every Linux distribution already, so you don't have to do extra installation or anything. And it's simple enough that you will kind of understand how scheduling works. It's mostly just once you know what scheduling is, and we know what to do. For example, we want to look at a minimum working example to do that. So that's what we. What's it? Yes, it's like a bot or a daemon or a service which calls another program at specified intervals of time. So, but so there are some limitations also for cron, especially when we're talking about professional settings. If you want to schedule something on a single machine, let's say if your data science team has a single server machine where you're building models and so on, then on that server you can schedule jobs. Okay, so schedule jobs using cron because it's mostly a single machine endeavor. Okay, so it will run a program within a single machine. But if you want to do things across machines, maybe there's a training server, maybe there's a Docker building server, Docker image building server, sorry, and other things, then across machines, it's kind of hard to use cron, and that's where Airflow, which is the next technology that we will briefly look at, comes in. So, so those are the, I guess, the pros and cons listed here. So cron tab is the way to specify the job. So we'll actually run cron tab in a second. We actually have an example, I believe. So there's a cron example folder inside our MLOps examples directory. We'll get there, but I just want to briefly mention this first, and then we'll look at that. So cron tab is a utility to specify, it's basically a text. It opens a text file, and you specify at what times you want to run a specific py file or a program. Okay. Yeah. So there's some subtle things to know about. For example, cron tab can be, so cron jobs or the scheduled jobs can be run both as a root user as well as a regular user. So in Linux, just like in Windows, so the administrator as well as the non-administrator. So both of them can run. So depending on who's running, the syntax may slightly change. But let's focus only on how a regular user is going to run. So the way you access the text file where you specify, hey, run at X, Y, and Z times is as simple as typing cron tab space -e. Okay, so let's actually do that. Okay, so let me go to ML ops examples and cron examples. So you can see the two files. But let's actually do cron tab -e. Okay. In fact, cron tab -e already gives you a nice set of documentation to specify how to schedule. So let me show that. So first time, if you run it, it will ask you which editor you want to use. I'll choose 3 for 3 or 2. Okay, let's use 3. So so it's basically a text file. It lets you open a text file as a user, and it's already saying how to specify a schedule job. Okay, so let's say you want to run a backup. Okay, so run a backup of all users on this machine at 5 a.m. every week. Okay, so there is this string here is basically capturing that idea. Okay, so to be able to run something at 5 a.m. every week, and the what follows is the command to backup, but we don't care about that at the moment. So let's actually see what is this string of 6 numbers. Okay, so string of basically 6 numbers plus some extra characters is exactly how we specify 5 a.m. every week run something. Okay, so let's see how it's done. Yeah, so that expression is called a cron expression. So a string of 6 numbers with some extra string of 6 numbers. Sorry, string of 5 numbers and the command. So that's called a cron expression. And so those 5 numbers plus some extra characters like star, minus, slash, and comma can be used to specify the schedule. Okay, so what are these 5 locations? Right, so 1, 2, 3, 4, 5 are the 5 locations for where you need to specify something, what the scheduling is, and then the path to your command, and the command has arguments. Okay, so command has arguments, and in fact we can see that here. This is the command. Tar is the command. Okay, tar is like a zip utility, WinZip or things like that. And then these are the command line arguments. Argument 1 is ZCF, so something, and then argument 2 is some file name like output of WinZip, and then input for the zipping of it. So anyway, there are 3 commands for this example. So let's look at what are these entries mean. Okay, so the first entry is the minute index. Okay, the first entry is the minute index. You can specify it between 0 to 59. The second entry is the hour at which you want to run your job. So 0 to 23. The third entry is the month, 1 to 31. Third entry is the day of the month. Okay. The fourth entry is the month itself. and the fifth entry is the day of the week. Okay. So it's the day of the week. Yeah. So if you come back to that example here, so you can see 0, 5, star, star, 1. Okay. So 0 means run at the 0th minute. Okay. 5th hour of the day. And star, star means unspecified, so no, not constrained. And 1 means on one of the days. I think it's Monday of every week. Okay. One of the days of this week. Okay. So every Monday of this week at 5 in the morning, run a backup. 5, 5th hour at 00th minute, run this backup. So yeah, I think there are some examples here in this that you can look at. So let's look at a couple, some more elaborate examples like this one. So if you want to run on the 5th and 7th day of the month, then you can do 5, 7. So this is some extra, I guess, syntax. Similarly, if you want to run every 2 hours, a job every 2 hours, it's hard to kind of write 0, 2, 4, 6, like instead of doing that, you can do 0 to 23 /2. There's just some conventions that were chosen for this tool. Okay. So if you want to list all the current commands, so if you don't want to edit it, of course you can edit it as well. So -E was for edit, -L for listing all these current jobs. So you can see that so if I list, there should be no cron, no jobs for the user, which is Ubuntu for us. And R means remove, but we don't have any jobs at the moment. Okay, so we'll now actually run a simple job just to finish the loop. So let's go to MLflow cron. Okay, so this is our job. Okay, run this job is just saying, hey, get the date and save it to date job every minute. Okay. Actually, I'm not 100% sure if this is the right syntax. Okay, we'll see. So to run the script, so we want to run this shell script. Okay, .sh means shell script, but it can be a py file as well. To run this, thing, so open the cron editor, cron tab -E, and then insert the following line. Right. So insert the following line is this line. So this, I think this is not correct, but let's change it. So let's just do this. So let me just save it like this and then move it to the other location, or we can actually. Yeah. So anyway, let's just leave it like this. Run this job.shell, and we are saying run it every minute. So all stars means no constraints on minute, hour, day of the month, um, month of the year, and then I guess day of the week. So there's no constraint. So it will run every minute, okay, basically. So let's actually see where it's storing. Okay, so tilde slash. Okay, so I'm just copying this to the root home directory. Home/Ubuntu was my home directory because I picked a Ubuntu my VM. If you use AWS, sorry, what Amazon VM, Amazon VM, then it's going to be EC2 user. So now, cron tab -E, you can edit it anywhere. So we'll add that. So I'm using the Vim text editor. Okay, so you don't. I guess it gave you an options to choose a few text editors. I chose Vim the first time. So the way to navigate Vim editor is up and down arrows, and whenever you want to edit, press I, okay, to get into insert mode. Whenever you don't want to edit, press an escape, and then you can navigate. So I could actually. I think I was doing something similar, right? So let's actually. Okay, so I copy pasted that, location of the file. Okay, so if I now look at list, it now shows, that there is, this was actually, we can delete that, but it just shows that there's one job running right now. Okay. So what is the job supposed to do? So if you type date in command line in a Linux system, you will see the current date, right? So in UTC, so it's actually plus 6 hours. But okay, so I'm trying to see if the job ran or not. Okay, so now you can see that something got created just now, date job every minute, right? And so it's basically, and it logged the first, when it ran. So you'll see that, 131.01, instead of that, it will be 132.01 and so on. So it's just a demonstration that Cron is, this is how it works. Okay? So basically, it doesn't require a lot of installations and other things. It's basically just a simple string to specify how frequently you want to rerun something, and then whatever file name you want to run. So it's not just use of machine learning in case you want to scrape a website or do some repetitive tasks, right? So maybe you want to trigger an email with a daily report for stakeholders. Those are things that you can run on using these types of tools. So any questions here?
Can you show the command to run the to use to run the
Oh, so cron tab minus E to edit the cron tab. So I'm here. Did you get the same prompt? So navigation is via up and down arrows, and whichever line you want to edit, you press insert. Okay, so you'll show at the bottom it's an insert mode, right? So that means I can edit now. So if I press T and backspace and so on. So older versions of Vim have an issue with backspace, doing some other things, but I hope it's not an issue for you. And then if you're satisfied, you do WQ, shift colon WQ. So so you can see that it's printing the date every minute. Any questions otherwise about cron? Oh yeah, you can notify, you can send emails to yourself or others at every scheduled time from a single machine. So of course, how do you send email? There is a email infrastructure that's needed to trigger, right? So for example, you can actually, for example, if you want to use Gmail, there are Python packages which, given the appropriate secret keys and API tokens, can actually send an email as a Gmail user from command line. There's also tools like notification tools, like which can trigger a webhook on a Slack channel, for example. So if a job has successfully run, you can, okay, sorry. So if you wanna on cron, you can schedule a job, and then once the job finishes, at the end, you can actually trigger, send to a Slack channel that something ran successfully, or send an email, or send a page, or SMS, things like that can be scheduled as well. Yeah. But cron is not really related to that. Cron is a way to run something periodically. That something has to have the capability to send an email or and so on. Yeah. Or not just to communicate, but also you can do other things like scrape daily the stock prices of a asset or things like that. You can do that. Yeah, with an always on server like what we have, right? So this server has been running for a few weeks now, right? So this server, if you have access to such a server, then you should be able to run many such Unity cron jobs if you want. Yeah. On your own machine, if you do it, except if you turn it off, then it's not going to run. Right? If you turn it off, it's not going to run. But once you restart the machine, it will run, especially for Mac users. Yeah. Okay, so let's actually take a break for 10 minutes. Resume at 7:45. Okay, so what we'll do now is actually do something similar that we did with MLflow, which is actually go through Airflow's quick start tutorial. That'll give us a basic idea of how to set up and see a DAG and how to set up Airflow. Okay, so I'm getting started. Okay, so Airflow is actually a Python package. Okay, so it's actually Python-based tooling. So that's why I'm introducing it in this course. So okay, so there is a few steps before we install Airflow itself. So you can see some steps here. So some environment variables need to be defined before we start installing Airflow. You can see that Airflow installation itself is just pip install some version, and so we will actually just copy this script. Okay, so we'll copy the script. Actually, there's a copy command right here. So copy the script into a file and run that file. So that's what we're going to do. So instead of that, we could also pick each line and copy and paste in the command line. That will also work. So this process is just going to install Airflow for us. Okay, so that we can now then get started using it. So let's do that. So let's go to Jupyter. For some people, the cron job is not running. Even for us, it's not running. Is it? No. Actually, it was running for us. So it's just that the text file that I had opened was not refreshed. But let's ignore the cron stuff now and install Airflow. Okay, so I'm gonna instead of copy pasting each command, I'm just gonna create a Airflow install.sh. Okay, so .sh is just to say that hey, it's a bunch of commands. Shell script is what we call it. But for our purposes, just think of it as a text file with some instead of calling it .text, I'm just calling it .sh. So I copied those lines. Okay, so basically in line 3. So by the way, things start with hash are just commands. Okay, sorry, are comments. So in shell scripting, these lines will be ignored. Okay, so these lines will be ignored, and then export is just exporting some variable to say, hey, where should Airflow be? Airflow version, Python version, and some constraint URL apparently that needs to be specified, and then it's just a pip install. Okay, so pip install is what we're doing. And then there's some initialization that's needed after Airflow is installed. Airflow is again like a tool that you can call on the command line, just like MLflow space UI. We can call Airflow. Okay, so and then Airflow will run at a certain port. So let's actually run this. Okay. So to run it, you can just do sh Airflow install. Okay. And it'll do that downloading of the appropriate package. It's using pip instead of conda. I think early on I said don't mix those two, so that sometimes conda may not keep track of pip specific versions that were installed. So there may be those issues, but for now we'll just use shortcut for now. Okay. So what did it install, right? So it's you can see the summary of things that it installed. Uninstalling and installing a lot of things, which is not good. Yeah, so you can see that. Okay. Now this is not about installation. It actually created something for us. You can see there's an Airflow directory. And it's doing extra stuff. So, okay, let's actually come back to what did it do. So we ran an extra command airflow standalone, which is what created those prompts. Before that, pip install actually installed and installed specific versions of software that were needed. It would have been good if we had created conda environments or like virtual ends and then ran this command so that global packages did not get messed up. Hopefully, that's the situation for us. Okay, so let's come back here. So you can see that it's already, it's saying it's actually, so the standalone last command actually started running as server. So let's see where. Okay, so up to this point was the installation. So it installed all these extra packages, and then starting Airflow standalone. Database is not initialized, so it's creating the database and all that. Okay, so the port, it's saying it's listening on port 8080. Okay, so we just need to export that port now, just to get a so that we can look at it from local. I mean, you can open the port to public if you want, but I think it's just safer to just tunnel it and see. So let's tunnel it. Yeah, now I'm facing the same issue that somebody faced earlier. I mean, if the tunneling doesn't work, I can just open the port for now. Yeah, I seem to have some issues. I'll just expose the port for now. I think oh, seems to have a lot of issues right now. the one quick check I want to do is see if that okay, I think I've lost my connection actually on this machine. Okay, let me actually briefly discuss Airflow while I try to debug this in real time. Um, okay, so the issue I'm facing is my remote machine crashed. It's not an issue with the Git bash as such. I mean, the machine that on the other side is not responding. So um, okay, so what I wanted to show was, okay, let's not worry about that. So I briefly wanted to mention uh, what what the Airflow documentation front page says. Airflow is a tool for authoring and scheduling and monitoring workflows. So what you get is you can define tasks. So basically Airflow comes with a bunch of moving parts. So I want to describe the moving parts first and then go back to the demo. I have another machine, so I'll show the demo there. But so what are the moving parts? So Airflow has a, this is a good. So Airflow has a scheduler, okay, and there's a collection of DAGs specified in basically text files. Okay, so basically, yeah, basically py files. Okay, so DAGs are specified in py files, and there's a scheduler which looks at the py files and schedules the jobs on workers. And this is where I guess there's a difference between Cron and Airflow. So Cron is like a one scheduler with only one worker, which is the machine itself. Whereas Airflow can, as long as you set up the configuration and all that, Airflow has knowledge of multiple machines available to it to run different jobs run different jobs in different locations. And so this is the key part. And then it also has a web server which is where we see which is what we are supposed to see access, which is the 888 8080 port forward thing, which is the user interface where you can see what the DAG is doing. You can click on it, you can see the diagram and all that. And then the scheduler, stores a lot of information about all these jobs. Like, did they run? Did they fail? Did they, what happened to the job? Okay, and that all can be accessed via web server. So these are the moving parts of essentially a scheduler, of which a subpart is an executor, which executes jobs, which are listed in that, which is listed in the py files, which is in a directory. These are literally files in a directory onto workers. Okay, so let me share my screen. Okay. Okay, so this is a backup machine that I have. So I will have to reinstall Airflow, but model that it will just work. So let me just do that. Give me 1 second. So in the meantime, is everybody able to install Airflow?
Is there something wrong with the installation itself? Like it does not complete and come back to the prompt. So that's where it stopped, right? Where yours stopped, web server, and that's it.
Yeah. So I think it's something to do with installation, some security. Let me repeat it here, and I can. So you should be able to see the. Okay, so this is the same thing. What I did is remove the Airflow standalone last command, which is what starts the server. Okay, so let's actually install this first. This will also probably do a lot of things. In the meantime, let's look at the. So in the code folder, just to kind of, we'll probably not be able to do all of this, but in the code folder, there is an example of setting up a Docker file. So let's actually look at the Docker file. Setting up a Docker file, which basically every time you create a container from the image, it just runs a wrapper script. Okay, so this Docker file is not for daemon purposes. It's not for ML deployment. This Docker script is for creating an image where once you run it, it just does some training and then terminates. It's just run some tasks and then terminates. Okay, so and so you can see that here, run transient pipeline is just copying some credentials which are needed for accessing or pushing data to Google. Okay, so this Airflow example pipeline is just doing what a recommendation system problem. It's building a it's computing some recommended movies, and then it's just pushing those movies to Google Cloud. Okay, Google Cloud has a managed database service called BigQuery, and so for that it needs some credentials. So that's what I'm passing here, and then it's calling recommend PyTorch to database. Okay, so this Py file has the steps where it says, hey, train the model, create the recommendations, and send it to BigQuery. So this example is really just creating a Docker image, and then Airflow, in Airflow, which we will see in a second, it's just calling it's just making us run one task. Okay, so which is just one Docker image, and that command is just on line 51. Okay, so it's just so in our examples folder, there's this Airflow pipeline example, and that the only file that is of relevant to us is that all these files, Docker file, PyTorch inference, PyTorch database, PyTorch train, they're all just to build a recommendation model and make predictions. Run transient is just a wrapper around that. And recommend Airflow is an Airflow relevant file, which is just saying how often you want to do it. So it says, hey, who's the owner, whom to email, email on failure and so on, some choices. And then it's saying what is the DAG. Okay, DAG is exactly directory acyclic graph that we've been talking about. And it's just saying this DAG has only one node. It's called T1, and that node has to have is going to run one command. It's called Docker run image. Okay? So it's a very simple DAG. It's only one node. There's no edges. It's just saying run that Docker file, run that Docker image, and so the Docker image runs. A container based on it runs, and then it just it trains recommendation model, saves the recommendations to Google BigQuery. That's the example. We will probably not do the example completely. Let's see where we are with the installation. Oh, I have some issues. Okay. I'm just creating a new environment. New, I guess it's like equivalent to virtual environment. Oh, wow. Oh, okay. I have some other issues here. Um, okay, I think I have some other issues. Let me stop sharing. Okay, I'll take a minute to kind of see if I can use the remote machine. I just restarted it, so. Yeah, sorry about the delay. Okay, so what I did is I was able to install Airflow. I mean, locally, some issue with my remote machine, it's not responding. So um, so this was the last command used in the previous script. I mean, the last line in the Airflow. Um, so the UI web server is running it here at this location, and the actual scheduler is running there. Okay, so so okay, what is the default username and password? Is there a default username and password? Um, okay, let's see. So what is the is there a username and password? No. Okay. Does is everybody at that level, or have they crossed? You've crossed the password thing?
No, we're still
Okay.
able to figure out the default password.
Oh, you're also at the same stage here. No? Oh, yes.
Yes, we're at the same page.
Okay. Uh, that's fine. I think we can actually. So Airflow, when you install Airflow, by default, it will create a folder here. And so this config file will have some details. So let's try. I mean, it will not be plain text, but let's see. What's it? Oh, standalone, this one. Okay. Okay, that was weird to save a password in the folder. But okay, so I guess I just wanted to get to this interface. This is not the, I mean, this is just a web interface for what is happening behind the scenes. Okay, so behind the scenes there's a scheduler, and what this web interface is trying to show is that there's a bunch of DAGs, directly acyclic graphs that are preloaded. Okay, these are all, you can see that they're all with a prefix example, so they kind of show how to run different types of jobs. Okay, so for example, let's take the simplest one, example bash operator. So it'll show, it's this is the DAG. I mean, you can see that there's a lot of stuff going on. So that's not the DAG, sorry, this is the DAG. If you click on the graph, so you can see there are multiple tasks. It's actually not a simplest example because there's multiple kind of simulated jobs or steps that are created, and we'll see the py file in a second where we'll walk through this. It just shows you at the graph level what needs to happen first. The leftmost things have to happen first, then this job will happen, then this job will happen. But for this job to happen, these three have to happen before that. So you can see that there's some sort of a hierarchy for jobs or programs to run, okay, or scripts to run. So you can actually see the code at this tab itself. So instead of looking at the folder, I'll show it to you in the folder as well, which is, if you look at the okay, so the examples are probably in the Airflow repository. So yeah, so but if we create a file like this, so just to kind of recap where we are. So if you go to Airflow, by default, when you start this Airflow standalone, the last command, which last command is this command, okay, Airflow standalone. If you run it, so if you run this whole thing, at the end of it, you should be able to get to something like localhost 8080 and just see this. Okay, there's just a web UI. There's a bunch of pipelines defined. So this is where, if one data science team has different models, churn model, recommendation model, marketing model, or whatever, uplift model. So all of them will be different pipelines. Some of them will be just ETL related. So here, you can, these are all examples. But if you wanted to create your own pipeline, you just have to create a py file. Okay, what is that py file? You can see the py file will look like this. Okay, it's just a file which specifies what the DAG is, and that's it. So it doesn't do much. So so you can see that, when you specify DAG is just an instantiation of a class. So you just have to say, hey, what is the name? At what scheduling interval you want to run this. So this is exactly cron syntax. Okay, 0th minute or 0th hour, every day, every week, every month. Okay, so it's basically every hour basically run something. Okay, with this particular thing, and there's a particular start date and all that. And then it has a bunch of what are nodes of the graph, okay, nodes of this DAG. Okay, so here the nodes of the graph are just given some names. Okay, run this last, run this, and then there's also an order that run this has to precede run this last. Okay, so this is how you specify in Python for a Airflow specification of a DAG. Okay, so it's not complicated. It's just the only extra thing is this type of syntax. Other than that, this is just instantiation of certain nodes. Okay, so what type of node? It's a bash node which just does echo 1. Okay, nothing else. Just echo 1. Instead of that, you can run a program. But yeah.
You have to write in all the syntax.
I mean, this is just a Py file, right? So it's just instantiating the DAG, and that's it. You have to write a DAG like this. Yeah. I mean, you write it once. Once you write it and schedule it, all these programs will run by themselves. Okay. So to come back to this DAG, if you look at the graph, this is it. So it's just saying these are the nodes that need to be run. There are like basically 7 jobs that need to be run. Okay. And this is actually currently off. So if we turn it on, it will run appropriate times. So you can actually see what is the scheduling time. It's every hour. Okay. If you turn it on and keep it on forever, then it's just saying that at some time 0000 hours it will run next run interval. Okay. So but not just that, you can actually ad hoc run it. So if you click the run here, or if you you can also do it via command line, but let me just do it via this. If you run this, you can trigger the DAG. Okay, so it's not in a schedule, but you can always trigger the DAG, and so it will show you what's being done. So what started with this green, there's some status. So you can see it's pretty slow, but even for the simple DAG, but it's basically because it's showing each of these operations. So it's just showing what all steps happen. So for example, each block is run after loop, and then run after loop. So there are several steps that happen. Okay, so so you can actually see the legend. So it was green, it was light green at some point, and then it became dark green, right? And some steps were skipped. Like I don't know what this step is. Run this last was a dummy operator. That's why it skipped. So I can run it again. So if you trigger it again, so you can see that the second run. Okay, first run happened at 00. So second run is happening here. You can see green means it's just started to run. Okay, and these gray means it's queued. Okay, so you can see things getting finished and succeeding. Okay? Actually, here you cannot see. So basically, this is this color. Okay? So it's just succeeded. So out, and given the time, we kind of lost because of some issues. So you can see, for example, Python operator. If you want to run a Python Python script, actually, let's see if it's a script. Yeah. So actually, it's running directly a Python function where sleep for some amount of time, and yeah, so it's actually running. So it's just calling my sleeping function. So these are just examples to get a feel for like what types of nodes can be created, whether they're programs, whether they're Python files, whether they're Python functions themselves. Ideally, you don't want to write Python functions in the DAG because this is more about management, not about your business logic. So you generally want to trigger another Py file somewhere else, which actually does the training or something else. Okay. So yeah, there are lots of examples. I think the tutorial is a good example of ETL, or these are all good examples of different types of DAGs that you can create. And actually, for the first one, you can see how many times it succeeded, how many jobs it skipped, and things like that. So it's just a UI to show you the state of affairs of all your pipelines. Let me actually conclude because we are literally running out of time. So what have we done today is really look at, initially we had a couple of comments about training, about testing. We saw StatSig blog page. We also saw, Amazon's A/B testing page. And we kind of briefly hinted at something called multi-on banners, which are just a slightly different use case compared to A/B testing. But last week we used planouts to kind of demo the simplest A/B testing example. Okay. And then today we started with versioning. So we tried out MLflow, and you saw that it really doesn't change much of your workflow, but it gives you a lot of added benefits. Okay, directly logging the parameters, directly logging the performance, all that. Okay, so it's a lot of ease of use that you get from using MLflow just with tracking. And now you can imagine with model deployments and ML projects, you can actually supercharge your workflow basically. So, and the last part we saw was related to retraining. There were two particular tools we tried to look at. One is Cron. We really didn't attach either one of them with actual ML works loads, but first one is Cron. It's kind of limited to a single machine, but it's a very simple interface and gets the job done, especially if you're in a single machine, you need to schedule things. The second tool is Airflow. Basically, you need to specify DAGs in Python files. So it's basically text files in which you say what are the nodes of a DAG and what relates to what. And graphically, we saw a couple of DAGs here, right? So this is an example of how the DAG looks like. Once such a DAG is specified and what the scheduling is specified, Airflow will take care of calling those appropriate functions or whatever programs and running it, okay, and on the schedule. And you can actually see how they performed over several days, and then restart and all that. Okay, all that logic is there. So with that, let's conclude. So next week we look at these multi-machine cluster situations with Spark as well as Kafka. Okay, thank you.